This video is over Chapter 31, the limit comparison test, and in particular, example 200. So for part A, we could use the actual comparison test on this. So we could compare 3 over n to 1 over n, but since this is the chapter on the limit comparison test, we'll use the limit comparison test instead. And we'll compare it to the same series that we'll compare this series to the harmonic series, which is a sum n equal 1 to infinity of 1 over n. So we'll apply the limit comparison test by calculating this limit. The limit is n goes to infinity of 3 divided by n divided by 1 divided by n. This simplifies nicely. This limit is 3, which is greater than 0. Since this series, 1 over n, diverges, the series 1 over n, the series n equal 1 to infinity of 3 over n diverges by the limit comparison test. I'll write LCT for short. But it diverges by the limit comparison test. Now remember, the limit comparison test can tell us that a series converges as well. Remember, the conclusion says if your limit is something greater than 0, then either both series converge or both series diverge. Okay. So it has to be a number greater than 0. Infinity is not a number. And now we have, for part B, we have the series n equal 1 to infinity of natural log of n plus 1 over n. And we'll apply the limit comparison test by calculating the following limit. The limit as n goes to infinity, n plus 1 divided by n, again, divided by 1 over n. Since we know that the series n equal 1 to infinity of 1 over n diverges, if this limit is a number greater than 0, then we'll know that this series diverges. So we look at this, and the first thing we notice is we have an indeterminate form of type 0 over 0. As n goes to infinity, n plus 1 over n goes to 1. Natural log of something going to 1 goes to 0. And 1 over n, of course, the limit as n goes to infinity of 1 over n is 0. So we apply L'Hopital's rule. Remember, L'Hopital's rule is not the quotient rule, it's L'Hopital's rule. We simply take the derivative of the numerator, then we take the derivative of the denominator. So the derivative of natural log of n plus 1 divided by n, we start by taking the reciprocal. And then the chain rule says we multiply by the derivative of what's inside. So this is a quotient, so we have the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator divided by the denominator squared. That is the derivative of this part. Then we have the derivative of 1 over n is simply negative 1 over n squared. This simplifies nicely. Distribute the negative through, the n's cancel. We have a negative 1 over n squared, which cancels with this negative 1 over n squared. And so we just have n divided by n plus 1, which is equal to 1, which is greater than 0. Therefore, the series diverges by the limit comparison test.